Welcome to The Explainer. Today, we're going deep, literally. We're going to look at the absolutely incredible engineering that lets us explore what is, for sure, Earth's final frontier, the ocean.
So get this, 71%. That's how much of our planet's surface is covered by water. And yet, for all our technology, it is still one of the least observed, least understood environments on Earth.
And here's the fundamental challenge, right? Seawater is about 800 times denser than the air we're used to. For us, it is a truly alien environment. We just weren't built for it.
So, that's the big question, isn't it? How on earth do we survive down there? Well, let's dive into the ingenious solutions engineers have come up with to take on the massive challenges of the deep. Before we get to the cool gadgets and solutions, we really have to understand the problem. The ocean is hostile. The biggest issue? Immense, crushing pressure that increases by one whole atmosphere for every 10 meters you go down.
And you know, this quote just nails it. Trying to study the ocean with satellites and robots is like looking at a rainforest from a helicopter. You get the big picture, sure, but to really understand what's going on, you have to be in it. You need to be immersed.
Okay, so let's get into the toolkit. We're going to start with the two most basic but most critical problems. How do you breathe, and how do you actually move around effectively when you're underwater?
And the first key invention, of course, is Scuba. The most common type is an open-circuit regulator. You breathe in from your tank, and when you exhale, poof, you see all those bubbles. But then you have more advanced gear, like rebreathers, which actually recycle your exhaled air, letting you stay down for much, much longer.
Now, for moving around efficiently, engineers did something really smart. They looked to nature. Modern fins have these awesome features, like vents that let water slip through on your upkick, which cuts down on drag. They've got side rails so water doesn't spill off the edges, meaning none of your effort is wasted. Some even have a split design that kind of turns into a propeller, giving you way more thrust with every single kick.
All right, so we can breathe and we can move. But now we come up against a much more complicated and totally invisible danger, the immense pressure of the water itself. And this danger has a name, decompression sickness, or as it's famously known, the bends. It's what happens when a diver comes up to the surface way too fast. You know, a really great way to picture this is to think about a shaken-up bottle of soda. You can't just pop the top, right? It'll explode. You have to release that pressure slowly and very, very carefully. It's the exact same principle. So here's what's happening. As a diver goes down, the pressure forces nitrogen from the air they're breathing to dissolve into their body tissues. A slow, controlled ascent with what are called safety stops lets that gas come out harmlessly through their breath. But a fast ascent, that's when the nitrogen forms dangerous bubbles inside the body.
And this chart just brilliantly illustrates the trade-off. It's so crucial. Look at this. At 15 meters, you can stay for about an hour without needing a long decompression stop. But go down to 40 meters, and you've got about 8 minutes. That's it. The deeper you go, the dramatically less time you can safely spend there.
So how do you manage all this? Well, modern divers rely on these amazing little wrist-worn dive computers. They're constantly tracking your depth and your time, and they run a complex algorithm based on decades of research to calculate a safe ascent for you in real time. It's like having a guardian angel on your wrist.
So you can see the pattern here, right? Time and pressure are the biggest limiting factors, especially when you think about huge jobs like deep-sea construction or long-term scientific research.
Which leads us to this fascinating, almost sci-fi question. How is it even possible for people to work for days or even weeks at extreme depths like 200 meters? The solution is a wild technique called saturation diving. The basic idea is, instead of going up and down every day and dealing with that pressure change, the divers just live at the same pressure as their deepwater work site for the entire job. Here's how it works. They get into a pressurized chamber on a ship. Then they're shuttled down to the work site in a pressurized diving bell. They work and live under that constant pressure. And only at the very, very end of the entire mission do they decompress. Just once. It maximizes their productive time and actually reduces the overall risk. Now, this is what's really mind-blowing. For a mission at 200 meters, how long do you think that one final decompression takes? About 8 full days. That's over a week spent slowly, carefully returning to surface pressure.
So all of this incredible technology and technique, it's all building towards the next great frontier, making permanent life on the ocean floor a reality.
An ocean technology company called Deep is really pushing this forward. And I love this quote from them. It perfectly captures the goal.
It's not just about getting elite divers down there. It's about opening up this frontier for scientists and researchers, just like we did with space.
Their pilot habitat, called Vanguard, is just a marvel of engineering. It's a completely self-contained living space for a crew of 4. It even has its own dive center, a moon pool in the floor, for direct access to the ocean. Plus, it's got multiple layers of safety systems built right in.
And looking ahead, Deep is using some seriously futuristic tech. They're using a method to basically 3D print with metal to build modular, self-contained habitats. Think of them like customizable submarines that don't move. And they're being designed to reach depths of 200 meters.
All this remarkable engineering really opens up one final, thrilling question. Just think about it. What secrets are we going to unlock when living in the deep becomes as routine for scientists as living in space? What will we discover?